Hello, everybody. Dr. White back again with a second screencast on considering categorical variables in OS section 2.2. This topic is the topic for this screencast is comparing numerical data across groups. In other words, investigating the relationship between a numerical variable and a categorical variable in a data set. So we'll consider the Math 111 survey data set again. So we'll run a little view and help if we need to. But particularly, I want to point out a numerical variable and a categorical variable to look at. So I'll be interested in the fastest speed a student ever drove the car. We've looked at that one before, alone. And seat, where a student prefers to sit in a class. And we've looked at that variable alone. But now we'd like to look and see whether or not those two variables are related. So here's our research question. Who tends to drive fastest, front, middle, or back sitters? So this being a question about the relationship between a numerical and a categorical variable, we're ready to go once we know some of the code that can help us to investigate the relationship. And turns out that favstats is a great way to investigate relationship between a numerical and categorical variable. Favstats, and then your parentheses because you're using this function. And you've got a little formula input where you put your numerical variable twiddles your categorical variable, which is, that's convenient because we kind of think of the numerical variable here as the response and the categorical as the explanatory, at least I do in my mind. That maybe if, quite often I find I get the impression in the class that like the people that sit at the back are kind of like, they're the daredevils, I don't know. And I would predict that they would drive faster. So I kind of think about seat as the explanatory in my mind. I don't know if there's really a clear choice about explanatory versus response in this situation. But what is clear is you're going to need to do numerical twiddles categorical, okay? And then, of course, the data set where the two variables live. And you will get this output in the console. Well, actually, you're going to get a little more. Let me just run it for you. So why don't you go along with me here and to our studio and copy this in for yourself, run and see what you get. And you do get a little more. So you get a row for each group determined by the categorical variable. You get a row for the front sitters, a row for the middle sitters, and a row for the back sitters. And you get a bunch of statistics on each group. So for example, for the front sitters, the slowest person drove 60 miles an hour. The fastest person drove 130 miles an hour. The mean speed driven for the front sitters was 102.25 miles per hour. There were 27 front sitters. Everybody answered the question. There was no missing. Nobody who was a front sitter failed to answer the question about their fastest speed. And similarly for these other groups. So a lot of different statistics here, and I'm just showing you a little selection of them, just the mean, the median, and the number of people in each group in these slides. So what you can do to describe the relationship is you can talk about differences that you see in one of those statistics as you go down a column. And so the number of people, that's not too useful to look at, but the mean or the median would be great to look at because they're measures of typical value. So like if I look at the means, I see 102.25, I see 102.9, almost the same thing. And the back sitters, I see 121.9. That looks like a big difference. And so I say, well, back sitters tend to drive faster than other people do. and I cite my numbers, mean speed of 121 miles per hour versus about 102 or 103 for the other two groups. So unlike a two-way table in R, for the favstats, you are going to compare values down a column because they are really running across the different groups. You could do a similar story with the median speed, 100 versus 115. 115 looks really different from the other two. And you could tell a story around that. That would also be a great way to describe the relationship that you're seeing here between the two variables. You can also describe the relationship graphically, and I'll just bring up a couple of different ways. One is with box plots, what we call parallel box plots. So what you see here is 3 box plots, one for each group as determined by the categorical variable seating preference. And so here's a box plot of the speeds of the people who prefer the front, the speeds of the people who prefer the middle, the speeds of the people who prefer the back. Now the group sizes are different. That has nothing to do with the size of these box plots. They're just trying to show like how the speeds are spread apart. So I'm looking at, as I look at these box plots, the easiest thing to do really is to compare the middle lines because those are the medians. And so you see that 100 versus 115, it's definitely higher. And so you can say that back sitters tend to drive faster than front and middle sitters do. There are other little differences you see, like the interquartile range. That's the height of this box here. For the back sitters, is like bigger than the interquartile range for the middle sitters. You can see those differences, but they're not as important in describing what typical speeds are like. This box here is basically higher than these other boxes, and you can summarize that by talking about the median. So how do you make those box plots? Well, there's a gf_boxplot function. And so it's working just like favstats, except it's going to give you a graph. Numerical variable twiddles your categorical variable. And where the variables live, what color do you want the insides of the boxes to be, and labels. And you should provide them for both the x-axis and the y-axis here, because they're both going to be meaningful. The x-axis is going to be the categorical grouping variable, and the y-axis is that numerical variable. Remember to give units whenever you can, like fastest speed in miles per hour. So that's the code that produced this box plot here. Okay. There's another type of plot, very similar, violin plots, that can show the relationship between a numerical and a categorical variable. This is called a violin plot because it's got like 3 things that kind of look like violins. I don't know. And what they really are is they're density curves for each of the 3 groups, okay? Stuck against each other in a mirrored way. So I'm going to illustrate this for you. This is not something you're going to have to do like on a test or anything, but I'm just going to show you how this little violin plot relates to a density curve for the fastest speeds for the people who prefer the middle. Okay, so bear with me while I go to RStudio, and I'm going to open up a little R script here, and I'll save it to my notes as, I don't know, speeds of middle sitters .r, sitters.r, and I'll save that to my notes. Okay, and remind myself that I need work. I'm going to need to attach tiger stats to my R session, and I'm going to create a little data set that's just the people who sit in the middle. And so it's M111 survey. And then there's a special little command we'll talk about in a minute called the pipe, %, %. And I want to filter for the seating preference to be equal to to_middle. So notice that's in my global environment here, and I'll just click on it to get a view. And everybody in this is a person who prefers the middle. There's only 32 people who would like that, okay? And now I'm going to do a little GF density, twiddles seat, data equals middle, this other data frame. And I'll go for like fill equals burly wood, comma, how about color equals black for the boundary. Yeah. And let's run that. And not seeing anything here in my plot. What, we got a problem, to middle. Oh, silly, how silly. I gotta do the variable that I want a density plot for, which is the numerical variable fastest. Okay, here we go. And pop it up. Okay, and so what we see is that of these 32 middle sitters, the curve is kind of high over the region from like 80 to 110. Most of the people prefer to drive that kind of speed. There must have been a few people that were willing to drive faster, and so the curve has this little right tail to it. So think that shape, okay? Keep it in your head, and then head back to the slides and look at this violin for the middle sitters. And do you see, if you just like draw a vertical line right in the middle, and then you look on the left side, do you see that density curve? And if you look on the right side, total mirror image is that same density curve. So a violin is really just the density curve for the group mirror imaged against itself vertically. So the way to read it is that where a violin is fat, that must mean that's where a lot of the people are. That the speeds for a lot of the people are kind of like down here in this kind of region where that violin was flat. And there's not going to be very many people in that group whose speeds are up here where the violin is thin. And there's nobody in that group whose speeds are up here because there ain't no violin here. So that's how you would read these violin plots. And again, you can get a sense that the backsitters tend to drive faster primarily because they have this kind of extreme tail heading off to the higher speeds. So here's the code for a violin plot. It's just like for a box plot, except that you say GF_violin. And I'll just go ahead and give this a try in RStudio. And pop up violin plot. Yeah, sure works. Oh, and by the way, I'm going to go ahead and save this little R script here. And since I'm done with it, I'll close it out. Okay. There's a nice twist that you can add either to box plots or to violins. You can add a layer of what we call jittered individual values. And so here's the same violin plot, but there's points thrown on top of each one. And each point stands for a person in the group. And how high the point is how fast the person ever drove their car. And the points are jittered. So that means they're not all going to appear exactly over the group name. They're not all going to appear over the one front. or the two middle or the three back. They're going to be jittered kind of randomly from the left to the right. That way, if two people drove the same speed, their points wouldn't lie exactly on top of each other. You could tell them apart. So how would you make something like this, which is much more informative, I think? It really shows the crowding, like down here, and the rarity up here. How would you make this kind of stuff? So the code for it is you make your violin plot just like before. And then you use this funny pipe thing, percent, and then bigger than, and then percent. And then you say, hey, I want to throw on another plot, like right into that same graphic, the jittered individual values with GF underscore jitter. And you got to say the width you want, the size you want, and the title that you want. So let's give this a try. I'm actually, at a moment, suddenly thinking I might have a typo in there. It makes it not work. So I'm going to give this a try. Yeah, it worked. Pop it up, and yeah, we get it. I'm not going to tell you what concerns me. I guess it's not a concern. So just things to note about this. This little piper guy is the way that you can like add a plot on top of another plot. There's a lot of cool uses for that. You might be interested in some of these parameters here, like width and size. The width, you can set it to be any number. The smaller you make it, the less the points are going to jitter from the left to right. I like width equal 0.25. It usually looks nice for separating the points out into their different groups. Size controls the size of the points. And here, the 0.5 is I'm basically making them half as big as they would appear by default. Hey, I'm going to try this again. Head back to RStudio, and let's just experiment. So I got the same command back up again by doing an up arrow. And I'm going to set the width to be like a 1 and give this a try. And pop it up. And you see the points now are jittered so far to the left and the right that it's kind of hard to tell which point goes with which group when they're like in between here. So see, that's just too much. Here, let me do another up arrow. I'll set the width back to 0.25. And let's play with the size. Why don't we set it to like 2? Try it again. And pop it back up. And all of these points are just way too big. It doesn't look pretty at all. So you can play around with options like that. And again, when you see code, copy paste, but also vary it, and you can really understand what the elements of the code are trying to do. Notice that you can also add a title to a plot, and you could either add it to the jitter part, or you could have added the title as another argument to the violin part. Either way would have got you your title for that plot. That's all the material for section 2.2. We should be heading into the DA now. So in a separate screencast, I'm going to give you a few prompts, kind of an introduction to the DA. See you soon.